OK, that's much better. So what I'm going to do is incredibly stupid. I'm going to run non-deterministic code live and see what happens. So when I was working on the video game that I was showing before, I found that there was an issue with the timer. Basically, I couldn't rely on the timer from the Elixir side as much as I would have hoped. And to show that, what I did is I wrote this little Elixir code that executes some WebAssembly, whatever. I just need something that takes a while to execute, so I am just calculating Fibonacci numbers. And afterwards, I send every 25 milliseconds the next call of this function. Very simple. If I run it, this takes a second because I'm capturing a bunch of samples. And what I'm going to do later is take this Python code, paste it here. And there we have. This is a graph of how long the distance between the consecutive calls of that function. So this is very naive, because what I'm doing is I'm scheduling 20 milliseconds after what I executed. And you can see here that the WebAssembly is not always taking the same amount of time. So this is bad. Better solution would be to do this. So what I'm doing here is executing the same Fibonacci number calculation, but I check what the current time is, and I do a send after with the difference from the 25 milliseconds that I'm targeting. So what does that do? And this always, obviously, always generates a different graph. So there we go. So my target was, again, 25 milliseconds. And you can see that it's always late. Well, not always late. Sometimes it's around 25 milliseconds, but it is always late. Also, not great. This means that if I'm executing, I expect this 40 times a second, and I am getting 35 or something like that. So different computers will desynchronize. So you're probably wondering, why didn't you just use send interval? What do you have against it? And this one does a send interval every 25 milliseconds. Again, the same thing. And that looks like this. And it always looks different, by the way. So I hope it's actually really slow today. There you go. OK. This one is more interesting. It actually averages out at 25 milliseconds. The reason it looks like it would be lower has to do with the fact that I'm rounding down when I calculate milliseconds from the microseconds. But it actually does 25. The reason this happens has to do with the way it works. When the timer hits the wheel, like when the timer wheel hits that it needs to call this function, it does, but late. And then the next time that the timer hits, the difference from the last time will be lower, because it is executing every 25 milliseconds, right? The timer triggers every 25 milliseconds properly. So you see immediately after a peak where it takes too long, it is too fast every single time. So it does average out to 25, but it has a ton of jitter. Why does this matter? Well, first of all, with 25 milliseconds, this is actually quite the variance, quite the jitter. And if you're having a microcontroller, for example, for a servo motor or some other thing, this will actually bite you. Solutions? Well, that would be another lightning talk. I ran out of time. So.